Math 170, Why Math Matters. I just wanted to spend a little bit of time going through Exam 1 study guide because the first exam is coming up and I want you to do great. So I'm going to share my screen and we'll just jump over to the study guide and we'll talk about it a little bit. I will put a link to this video in the study guide. You can see right there as soon as it's done. And also just as a reminder, we've got this master course schedule, which you can always go to, take a look at and see like everything that's happening and when and where with all the links. So pretty useful there. There's some notes on preparing for an exam. Essentially, like to me, it seems like people should know these things. They're obvious, but really reading through this and understanding that there's sometimes you study hard, but not smart. You don't study all the stuff you're supposed to study. You just study a few things, you get good at them, and then all of a sudden something else is on the test, and that's not great. So make sure to study smart. That means studying enough, but also studying maybe with other people, quizzing each other, coming into office hours when you get stuck, not spinning your wheels a whole bunch. Just like if you can't figure something out, get some help. And we've got myself, I got office hours. We have our tutors with office hours. There's a lot of great things you can do to study well. And then I would say also, it's always important in an exam to make sure that you kind of put yourself in a position where it's all on you before the exam to figure out and do problems in a timely manner. So just you can read through some of these hints for studying. But I think this can be an exam that you do really, really well on. And let's hope for that and prepare for that. You got lots of problems to work through in the pre-exercises, the homework sets, the course lectures, lots of videos. You know, if you forget how to do something, you can always go back to that video. There's the short pre-videos, and then there's the longer videos, the full lecture videos with more problems of the same type. So, you know, find your problem spots, use this study guide as a guide, and go back and just make sure that the things that you're not sure about, you're learning and practicing. Also, make sure you have a calculator, a scientific calculator with parentheses. That'll be a big part of the exam. There'd be even a part where I ask you to write out the keystrokes required or the code for the calculator to input a big formula all at once. And no, your phone is not acceptable as a calculator. All right, we basically have 4 kinds of problems, and we have some associated financial formulas. You will be given all of these formulas exactly as you see them here on the exam. So you can't have notes on the exam, but I'm going to give you these formulas, and you have to know what they stand for and how they can help you, as well as what the given inputs mean. So we'll just go over them real quick right here. Formula number 1 is the only simple interest formula that we have. And if a problem says simple interest, you have to use it. And if a problem does not say simple interest, literally the word simple interest, then don't use it. Number 2 and 5 and 6 all go together, so you can kind of look at them as it is a formula, but they're solved for different things. So number 2 is the compound interest formula solved for future values. So compound interest, remember, is the principal is one big lump sum investment, and you don't keep putting money into your investment. You just put it in, and then you calculate F, which is the future value, like what the money turns into is the future value. If you take that and you solve that formula for R, the interest rate, then you can answer the question, given some sort of investment that's a single deposit, what interest rate will you need for the future value to be a certain thing if you start with some P? So this is exactly number 2, but solved for R. And also when you're encoding with the calculator, remember, when you have things like a fraction, this 1 over nt, you need parentheses around it, especially in this case, since it is a power. And also this nt in the denominator needs a set of parentheses. So if you're going to write out the codes, which I will not give you, but you need to learn to translate a formula into a code, then make sure to get parentheses around your fractions, top and bottom. Number 6 is also number 2, but in the context of solving for t. So 2, compound interest, solve for r and t, are 5 and 6. And what I'll do is we're going to have a matching section on the test. So I'll just give you a paragraph, and it's a problem that you don't have to do, but you just have to identify which formula best matches that problem. So if I say something like you have $100, you invest it for a while, and you want it to turn into $500, how long is it going to take? Well, the how long question means it's a t, it's a solve for t, which you can see there's 3 equations solved for t. So anytime it says how long, you know you're going to use formula 6, 7, or 8. But if it's a single investment and it's a how long question, then it's going to be formula 6. Formula 3 is our repeating deposits formula. So this is where you're not putting in money one time, you're putting in money over and over and over, like $500 a month or something like that. And so you can see D is the deposit amount, F is always future value. And of course, in any of these top line problems, the first row, we could ask for like, what is the deposit necessary if your future value is, and we could know like the end amount that we want. And then these are easy to solve for D in this case. You would just divide by all of this stuff. Making sure, of course, when you put the code in the calculator that you get an extra set of parentheses around the top of the fraction, the bottom of the fraction, and this power, this NT is going to need a pair of parentheses. And now if it's a question about repeating deposits, but they say, how long will it take? Then that's where you jump to number 7. Number 7, make sure you have parentheses around the bottom of that fraction, the whole thing. The top doesn't really matter because it's all contained within the log. You don't need an extra set. It wouldn't hurt you, but you don't need it. And then number 4 is our loan formula, the regular kinds of loans. They're called amortized loans. P is the loan amount. R is the regular payment. But if the question is, how long will it take to pay off this loan, then you have to jump to 8 because 8 is the loan problem solved for time. And again, make sure that when you're encoding this in the calculator, you're putting parentheses around the whole bottom of the fraction. The top of this fraction, again, doesn't matter because there's a log there. But encoding number 4, make sure you got a set of parentheses around the top, a set of parentheses around the bottom, and then another pair around this power, this minus NT. So be ready to know what those are. I'll give you all the formulas. And then the way that you'll show your work on the exam is you'll write in inputs for all the different letters, and then you'll just type in to your calculator, whatever it is, the code, and you can just write the answer. So you don't have to write lots and lots of steps, but you do have to write in the inputs, put it into the calculator, and hopefully you get all those right. So there will be a matching section where there will be formulas that you just say, Formula 3 will answer this question. And then there, of course, will be a section where you actually have to do some problems. Let's see, what else do we have? Oh, interest is an important thing. Remember, interest is like a rental fee on borrowed money, whether the bank sort of borrows it from you when you're investing, and then they're going to give you interest back, or whether you borrow money in a loan and you're going to have to pay back more. So with simple interest only, we can use this I equals PRT formula, but that's not what happens most of the time. Most of the time, we need to figure out the interest in general, and that's just the future value, like what your money turns into, minus P, the principal, what you put in. Now, sometimes that's a little bit tricky because if you're doing a repeating deposits problem, the money that you put in is a whole bunch of repeated deposits. So the deposit amount times N, which is usually months. So it's usually like $200 times 12 months times 5 years or something like that. That's the total amount of money put in. And you take that away from the future value, and the difference between those two is interest. And if you're talking about loans, figuring out the interest that you have to pay, that's the total paid. Remember, RNT, your monthly payment, like if it's $2,000 times 12 months times 30 years, that's how much you pay out, minus the principal, which is the loan amount. So the difference between what you pay back and what they gave you at the beginning, that's how much interest you have to pay. We talked about problem recognition, identifying the correct formula. I think there might be one multi-part problem on the exam, and that's sort of like the type of problem where you say, I have $10,000. I want it to turn into $20,000 in 6 years. Here's the interest rate. And you realize that it's not going to. If you just put that $10,000 into the bank for 6 years, it turns into like $15,000, which isn't enough. It's not 20. So then you have to do this other part. You have to say, I need to save $5,000 with repeated deposits. So that $5,000 would be your future value for some repeating deposits, and then you could solve for D. Also, for sure, there is an amortization schedule problem, and I think it's pretty heavily weighted. I think it's 18 points on the exam. And so I just thought I'd write out some steps for creating an amortization schedule. If you want to get these points, you will, because you'll just practice this over and over again initially. So this is just a schedule or a chart full of the information that happens numerically when you're paying off a loan. So you start with the period, usually it's months, and then you have the balance at the beginning of the month and your monthly payment. That payment is split into two parts. The interest that you pay, that's the fee, because the bank has loaned you money and you have to pay a fee every month. And then the rest of that payment is principal. So interest plus principal has to equal the payment. And then the ending balance is just what the balance was at the beginning minus your principal. And so what I did was I just wrote some steps here, some math steps for you to be able to fill out a row and then repeat yourself for a amortization schedule. A couple of things here, just the monthly payment. Here's the code for R, the calculator code. And so that makes it pretty easy. You just have to type those in as keystrokes on your calculator to get R, the regular payment, and that's going to go right here. And then the interest is how much you owe each month. So what you do is you take R divided by N, that's your annual interest divided by the number of payments, which is usually 12. And that's like the percent you pay each month times your present balance, because you're always charged interest based on what you owe right now. And that will change every row, and it will keep going down and down and down because you keep paying off your loan. So your present balance is smaller. Remember that the principal part of your payment is what's left after you subtract the interest. So the payment minus the interest is the amount that goes toward paying down your loan, which is why the ending balance for that month is the beginning balance for the month minus the principal. And that ending balance for 1 month then will become the beginning balance for the next row, the next month. And then you just keep going and going and going. And when your ending balance is 0, the loan is paid off. So hopefully that helps a little bit. There's always going to be a memory verse. This is one of my favorites. So memorize that, write it down on the exam. And if you wear eye black, like Bryce Harper, you also get a bonus point. You don't have to wear it like Bryce. You can just go like straight across or whatever. There's many forms of eye black. There's tape. There's permanent markers. There's non-permanent markers. It's a good time. So hopefully this helped. I want you to do well. Reach out if you have questions or need anything else, and I will look forward to seeing you soon.